You've always wanted to learn about category theory, or as mathematicians call it, generalized abstract nonsense. Now, what is category theory? Category theory is the mathematician's way to do object-oriented programming or design patterns. A category is simply built from objects and morphisms, and the morphisms have to satisfy certain laws. In particular, when you have a morphism from A to B and another morphism from B to C, you have to have a morphism directly from A to C as well. Now, let's take a step back and take this category and make categories as objects so that we get this picture. Here we have the categories now as objects, and we need to have a notion of morphism. Well, that morphism is called a functor, and the category is called the category of small categories. Now, if we look at the rules for functors, what we recognize is that the functor, when applied to object, is really a generic type. And when it's applied to morphisms, we see that it's the familiar map function. We can take yet another step back and look at functors as objects. And when we use functors as objects, we need, again, a notion of morphism, and those morphisms are called natural transformations. And if we look at that with our developer glasses, we see that natural transformations are nothing more than generic functions. And this category, by the way, is called the functor category. Again, the morphisms in a functor category, these natural transformations, have to satisfy particular laws, and the usual way to write those is with a computing diagram like this. So if you go from the top left to the bottom right, you can go in two ways, and the law says that it doesn't matter which direction you take. Well, I know which direction you should take. You should come and do this MOOC. See you soon in cyberspace.